So for part 2 and 3 of homework 8, we are to add an additional sensor. So the first sensor detects if a car is in the east-west direction, and the second sensor detects if a car is in the north-south direction. So here you can see my finite state machine. We're going to start at north-south is going to start in the green at a green light, while the east-west will remain red. If a car is detected, then north-south will start to transition to a yellow light. Otherwise, north-south will just stay, the north-south direction will just stay green. If a car is detected in a north-south direction transitions to the yellow, then east-west is going to remain red until north-south transitions to a red light, and then the east-west direction will be able to go and it'll be green light. And then if a car is not detected, then east-west will remain green. Otherwise, if a car is detected in the north-south direction, then east-west direction will begin to transition to a yellow light, while the north-south will remain red, and then it will restart back at state 0, where we have north-south going again or transitioning to a green light. So for my code, is very similar to my first traffic light controller. This time I named it traffic light controller 2, and I have the additional sensor. My first sensor was car east-west, and now I have a second sensor, car north-south. And I also have my reset and my clock. And then I have my north-south and east-west direction, which is still 3 bits because my green light is 100, my yellow light is 010, and then my red light will be 001. So for the architecture of my traffic light controller is very similar to the first one. I have my current state and next state signals. I also have my process that includes a clock and a reset. So if my reset is equal to 1, then my current state will be state 0. And if the clock event and the clock is on and on a rising edge, then my current state will equal my next state. So here in my process, similar to the first, I have my current state, my sensor for my east-west direction, and now I have my sensor for my north-south included. So then when I'm in state 0, my north-south will begin in a green light, and the east-west will remain red. If a car is detected in the east-west direction, then I'll go to the next state. Otherwise, north-south will remain at a green light. So at my next state, and this is following my finite state machine. At my next state, north-south will transition to a yellow light, and the east-west will remain red. And then when my north-south transitions to a red light, the east-west direction can go. If no car is detected, it will remain a green light in the east-west direction. If a car is detected in the north-south, then east-west will start to transition to a yellow light, and so on and so forth. Here I have my test bench. I have my entity, my architecture, where I instantiate or declare a component, which is the same as the entity for my traffic light controller 2. I have my inputs, my input signals that I set equal to 0, and then my north, south, and east, west direction. Then I instantiate the unit under test where I assign my signals to the inputs and outputs that I use in my traffic light controller 2, which are the same. Then I have my clock process and my stimulus process, which this will allow me to go through the states. So here I'm going to show you my simulations for my traffic light controller 2. So for up here, this is my detector, my sensor detector, my sensor that will detect if a car is in the north-south. This one is a sensor that will detect if a car is in the east-west. I have my clock, my reset, and then this is the north-south direction, and the bottom one is the east-west direction. So here you can see like my finite state machine. The north-south is going to start green, and the east-west is going to begin at a red light. And so there's a car detected in the east-west direction, so my north-south direction will start to transition so the east-west direction can go. So then I'll have a north-south, my north-south transitions to a yellow light, and then it transitions to a red light, and my east-west direction will begin to go. And here you can see that there's a car detected in the north-south direction. So if there was no car detected, east-west direction would stay in green at the green light. But since there is a car detected, east-west direction will start to transition to a yellow light, and then it will transition to a red. And while east-west direction is green, you can see north-south is remaining red. And so here I'm at my reset state, where it allows my north-south to go green again, and my east-west remains at a red light. It will remain green until a car is detected, and if a car is detected, then my north-south will transition to a yellow light and then a red light, so my east-west direction can go, and it will continue to simulate like this. And this is my simulation of my VHDL code and diagram for problems 2 and 3, which both follow problem 14.6 on homework 8.